Right. Hello, everyone. Good afternoon. My name is Jordi Barrera. I'm from Open Cosmos, and I'm going to present you a new approach to develop missions and execute them. So I guess probably not a lot of you have heard of Open Cosmos, so I'm going to do a brief intro. So Open Cosmos, we provide simple, affordable access to space. So we are trying to solve three major problems that we've seen through our professional life and our customers telling us. So technology, paperwork, and cost. So the technology problem is people, as we've seen like this morning, develop science missions, develop payloads, but sometimes they lack the knowledge or they lack the information on what CubeSats can do. In order to bring those missions to detail, they need to have that knowledge on board. That means to have multidisciplinary teams across different fields. Paperwork is underestimated or overlooked, or sometimes it's even unknown. And then the cost of developing those missions is still pretty high. So how do we want to solve that? So the Open Cosmos solution is a mix of products and services. On the product side, we've got hardware and software. So on the software side, we've got Jordà, which is a cloud-based systems and mission design, analysis, and simulator tool. We've got QBKit, which is a hardware development, payload development kit. And then we've got QB, which is the nanosatellite platform that supports those payloads once in orbit. Open Cosmos provides then all the services you need to get a successful mission. So that would be the ground segment, frequency rotation, launch services as well, and all these at a reduced cost. So how does this work in practical terms? So people starting a mission, they start with QBKit, with the payload development kit, and with QBApp. So with this kit, they can integrate the payload in it using the same electrical and mechanical interfaces as they would see on the nanosatellite platform. And through QBApp, they can define all the system and mission parameters. So this allows, from the very beginning of the concept of the mission, to take into account those mission requirements to drive the payload design. So you can run system end-to-end tests, taking into account those parameters. Once the mission developer is happy the payload is flight ready and the mission is fully defined, Open Cosmos integrates the payload into the QB nanosatellite with the same specs as they have defined on QBApp. We then procure the launch, we take care of all the systems, we get it into orbit, and then the mission developer can operate that payload, can operate that mission using QBApp with the same interface as they've been using during the payload development. So this reduces mission risks by putting the system end-to-end tests, taking into account the mission boundaries at the very beginning of the mission. You ensure also full compatibility of the payload with the platform and the mission requirements. And also you use an operation system which is end-to-end tested, reliable, which reduces operational risks and manages the ground segment for you as well. So how do these products look like? So this is QBKit. So QBKit is the hardware payload development kit. It's got the same mechanical and electrical interfaces of the QB nanosatellite. And it's got a modular structure which enables the mission developer to have the size of the satellite as just another variable during mission development. So when you start a mission, sometimes you don't really know what size you will need. That iterates depending, for instance, with the power needs, with the pointing needs, or the size of the payload might change. With QBKit, QBKit acts effectively as a black box for the payload. So it's driven by QBApp, it's controlled by QBApp. QBKit feeds the payload all the inputs and outputs that you would see on the nanosatellite platform in orbit, driven by QBApp. QBApp, it's the cloud-based software which enables simulation for systems and mission as well. So you can define all your system parameters, you can define the configuration of the system, you can define the mission parameters, and then you can analyze the mission, so you can see all your power budgets, all the data budgets, you can see if that complies with the mission requirements, and then you can feed that back to QBKit, driving the payload system end-to-end tests using those parameters. So all this done is in a like operating system agnostic platform that you can operate from your browser. QBApp also, once the payload is in orbit, it manages all the ground segment for you, so you don't really have to worry about which are the antennas that are being used for the mission. And then, as I said, so this is just a single software from payload development to in-orbit operations. So QBApp is really taking you from mission concepts up to orbit. So QB is our nanosatellite platform. So it's got obviously the same mechanical and electrical interfaces as QBKit. We've designed QB with the system architecture that is highly modular and capable. So that enables us to offer our customers a wider range of subsystems to meet their mission requirements. So we've seen, for instance, today some interplanetary missions that have got quite challenging requirements and a variety of requirements as well. So mission developers are really asking for this flexibility. Something that we've done as well, we've implemented, is a payload processing unit. So we are effectively decoupling the platform from the payload. So this again brings even more flexibility to all mission developers. They can run their own scripts on the payload processing unit without endangering the mission. And finally, I just wanted to touch on some notes on which are features on the QB nanosatellite platform that could be applicable to interplanetary missions. So the mechanical systems architecture that we've got on QB allows independent thermal management for each subsystem. We've seen that thermal management in interplanetary systems can be quite challenging, even more challenging than in LEO. So our mechanical architecture allows those systems to tailor the environment for those systems and for the mission. Another key thing is CubeSats, by definition, they use commercial off-the-shelf components, which there's many challenges on the radiation, and that's quite specific for interplanetary missions. So the approach we've taken is a distributed fail-safe architecture. So there's hot redundant systems watching each other. We've minimized a single point of failures. And also, by default, the subsystems, they contain radiation protection as well, which helps to reduce the total ionizing dose, increasing a bit the lifetime of the mission. So, I'm really excited. I'm really nervous, I would say, but I'm really excited to see this morning, like, all the developments here happening on the science community regarding interplanetary CubeSats. At Open Cosmos, we've got a really hard-working team working to help you guys to deliver those successful missions. So please talk to us, come and join us to help to explore all these new challenges. Thanks.
Okay, we can open the floor to some questions. A bit of a non-question, more like a comment. I'm assuming that the QBApp currently doesn't support the ground segment interplanetary.
It doesn't. No, interplanetary ground segment is something very specific. So the backend infrastructure of QBApp is geared at the current moment for LEO missions. It's something that we build the backend in a quite modular way as well, so we can add modules to it. So there's nothing technically stopping us to connect to interplanetary like antennas that could be used, like bigger antennas, or to interface to third-party systems as well, that they might have that infrastructure. So it is possible, it is not yet done.
One question, I'm not sure, I'm curious that which are the potential customers of Open Cosmos could be like universities or any companies or whatever can, like, I want CubeSat to be launched.
So anyone who wants to develop, like mainly as we call it, get data from orbit, that's a customer. So people who want to develop missions and they are developing the payloads, being either privately held companies, being organizations, being space agencies. Sometimes these customers, they don't really want to take care of the rest, or they cannot take care of the rest of the mission. So those would be our customers.
And and is there any process of discarding some missions? Because if we are all launching to LEO orbits, I think until now, if there are too much missions demands with a lot of CubeSat in a couple of years or something, so it's like any process saying no, you cannot launch because it's not. We prioritize this kind of missions because they are better or well planned.
So there's going to be restrictions on the legal side as well, on the launch side, for instance. So launches are still pretty limited. And mainly on interplanetary missions, they are even more limited. So that's kind of the limitation right now. In terms of our internal capability, so we are setting all the processes on the company app to deliver like 12 missions per year. So on our side, the infrastructure is highly scalable. So we don't see it being the bottleneck.
Thank you. Where do you see these CubeSats being registered? British or elsewhere?
That will depend on the customer. So some customers that we've had discussions with, they want to own the registration, so register the space object themselves. If Open Cosmos has to do it, it's going to be in the UK.
So my follow-up to that is, how are you handling the insurance?
The customer pays for it. This is something that in the UK, it's kind of let's say, it's put against us, or against, like, we are in disadvantage compared to some of our competitors worldwide, but it's something that we have to deal with. Yeah. So we've already looked at, we are in talks with the UK Space Agency about all this.
Are there any missions that you've launched or have in the pipeline that you can talk about?
Yeah, so Open Cosmos as a company, it's got one satellite up in orbit, being commissioned as we speak, which is QB01. So this satellite was developed from scratch to delivery in less than 6 months. But it was launched, it was deployed from the ISS 2 weeks ago. Just launches take long. This satellite, I guess you want to know some details. So this satellite is part, you might have heard of the QB50 consortium, QB50 scientific mission. So it's got one of the QB50 payloads in it. And then it's got some of our own technology in it as well. We are testing software, we are testing all the backend for QB app, all the ground segment infrastructure. So we are using it as a testbed for the company, apart from delivering the science mission as well. And we've got some missions as well in the pipeline. Like, what's the news today? There's a big announcement coming, or already has happened, I guess, probably about an hour ago.
Any further questions? Okay, then let's thank Jordi once more.